We will now solve problem 5 given at the exam in the fall 2017. Okay, the first thing we notice is that we have a lot of sub-assignments. We have from A to L. And remember that all of these sub-assignments are weighted equally as one sub-assignment in problem 1, for example. So the A of problem 1 is equally weighted as the G in problem 5. You will also note that the first ones are fairly simple and the last ones are more complex. Still, they're weighted equally. So please do the ones you're sure of first. Okay, in A, find the first and second derivative. Okay, that is fairly simple. You should be able to solve this at the exam. I often write f of x first, and then I find the first derivative, 2x minus 6, and the second one. And here you can use the tables given in the attachment. B. Find the calculation of the vertical intercept. The vertical intercept is where the graph crosses the y-axis. And in that case, we have x equal to 0. So what we're basically asked is what value does f of 0 have? So we simply put in x for 0 and get out 5. So this point here would be 5. So the vertical intercept is 5. This was a random function, so don't connect that directly to our function. Okay, in C, find by calculation the points where the function intersects the x-axis. So now we need to find the intersections with the horizontal axis, the x-axis. And this is where the y is equal to 0. So if our function is y equal to f of x, we need to figure out when that function is equal to 0. And it is said that we're supposed to do that using calculations. We could also, if we had the graph, we could plot it and just see where it crosses the x-axis. But now we're going to do it using calculations. Okay, so this is a second degree equation. So we simply applies the quadratic equation. You can find that in the attachment, the formula sheet. We often call it ABC formula. Right, we have a x squared plus bx plus c equals to 0. And then we get x equal to minus b plus minus b squared minus 4ac divided by 2a. In our case, our a is equal to 1, b is minus 6, and c is 5. So we would get 6 plus minus 6 squared minus 4ac divided by 2a. 6 plus minus, here we have 36 minus 20. Remember that minus 6 squared equals to minus 6 times minus 6. So we have a minus and a minus, so you get plus. Okay, divided by 2. Let's continue. Then we have 6 plus minus square root of 16 divided by 2 still. We have x equal to 6 plus minus 4 divided by 2. So we have x equals to 3 plus minus 2. So the function intersects the x-axis at x equals to 3 minus 2 and x equal to 3 plus 2, 5. So 1 and 5. That was C. Now we're going to D. Find the output of the function when the argument is 2. Okay, this is simply to check that you understand what we mean. So we have f of the argument 2. So we have x squared minus 6x plus 5. So we get 4 minus 12 plus 5. That equals to minus 3. The output of the function when the argument is 2 is minus 3. I often write it in text since the question is asked for in text. So that was the first part of it. Calculate the equation of the tangent to y equals f of x when x equals 2. So we have a function and we would like to know the equation of the tangent. That was an awful drawing. But you can imagine a straight line. That was much better. Tangent to that point. So we have 2 here, and we have minus 3 as the y value in that point. Okay, we need to first find the equation to a straight line is y equal to ax plus b. Where a equals to f first derivative of 2. Because the derivative of the function in that point is the gradient of the tangent. So a is equal to f derivative 2, which would be 2x minus 6, so minus 2. Now we have a lot of different ways to calculate this. But we now know that y is equal to minus 2x plus b. The only thing we need to figure out is what is b. We know that we have a point. The point xy equal to what we have here, 2 minus 3, is on the straight line. So we could insert that. So we get minus 3 equals to minus 2 times 2 plus b. So we get minus 3 plus 4 equals to b. that would be 1 equals b. So the equation of the tangent is y equals to minus 2x plus 1. Okay, let's continue with E. What are we asked for then? E. Test if the function is odd or even. That is given every year, almost. And the easiest way to do that is to figure out with minus x. So if it is even, then we will have f of x equal to f of minus x. For example, here, if we have some kind of function like this on the plus x side, we need to get the same thing on the negative side. Right, so it could be a lot of different things. If we have, for example, this stuff here, we need to have the same on the other side. If we have this, we need to have the same on the other side. So whatever we have on the left or the positive side, we need to have on the negative side also. So we can mirror it around the y-axis. So let's check. We simply put in minus x. First we had x squared minus 6x plus 5. So we exchange all the x's for minus x since we did it on the left-hand side. This will give us f of minus x equals to x squared plus 6x plus 5. And that is not equal to f of x. If it would have been a minus here instead, it would have been even. Okay. Yeah, so you need to put a conclusion here. Not even. If it is odd, then we will have f of x equals to minus f of minus x. So, for example, if we have x and y here, if we have this one, we need to have something like this. If we have something like that, we will get something like this. And if we have this, we will get something like, oh dear, this. So the thing is that you rotate whatever you have around origin. So if we look at the black one here, this is x. We have some value here, which is f of x. And if we rotate it, we have minus x here. We would then get minus the value we had here. Okay, so let's check. F of minus x would be, again, let's put the minus in front here also. So we have a minus in front of everything. Minus x squared minus 6 plus 5. So again, we have a minus in front here. So you need the minus in front here. And then we exchange all the x's for minus x's. Okay. This will give us minus f of minus x equals to minus x squared plus 6x minus 5. Plus 5, sorry. Minus f of minus x equals to minus x squared minus 6x plus minus 5. So if we compare with the original function, f of x equals to x squared minus 6x plus 5, you'll see that now we have the minus here, but now we have minus, and that is okay. But as you can see here, we have a minus in front of x squared and a minus in front of the 5, where we should have had pluses. So this is not equal to f of x. So this one is not odd either. Okay, so basically you'll find that it is either even or odd or none of them. That was it. So the functions that I've drawn, the graphs here, that is simply for explanations in this video, and you should not include that in the exam. F, is the function a one-to-one function? The reason for your answer. If it is, find the inverse. Okay. F. So, is it, if it's one-to-one, you cannot have that multiple input give the same output. If we look at our results here, for example, in this one, in C, we found that the two different x values that gives f of x equal to 0. So this function is not one-to-one. F of x is not one-to-one since several inputs have the same output. For example, f of 0 equals to 0 squared minus 6 squared plus 5. That was not what I wanted to show you, sorry. I wanted to show you the points we had in C. What was it? One more time. In C, yeah, you can see here that we have x equal to 1 and x equal to 5, not 0. Okay, one more time. So we have f of 1 and f of 5. So here we have 1 squared minus 6 times 1 plus 5, which is equal to 0. Here we have 5 squared minus 6 times 1 times 5 plus 5. So this is 24 minus 30 plus 5. So it's also 0. And this we have from in C. Okay, G. Luckily here, if it is, find the inverse. We don't have to find inverse because it's not a one-to-one function. Okay, find all the stationary points by calculation and determine if they are local maximum or minimum points. In stationary points, the derivative needs to be 0. That's simply because we need the tangent to be horizontal. So in the maximum or in the minimum point, we have horizontal tangents, and since the derivative is the gradient of the tangent, that has to be 0. Okay, 2x minus 6, which is the derivative of x, needs to be 0. So 2x has to be 6. So x has to be 6 divided by 2. X has to be 3. Okay. And f of 3 equals to 3 squared minus 6 times 3 plus 5. So it's minus 4. So the point x, y equal to 3 minus 4 is a stationary point. Okay, just one quick note here. You asked for the stationary points. We only find one point. X equals to 3 is not a point. Xy is a point. Therefore, you need the y value also. If you only answer it with the x value, x equal to 3, you are just answering half the question of the point. That was the first part of G, if I remember correctly. Find all stationary points by calculations and determine if they are local maximum or minimum points. So we have one stationary point, and now we need to figure out whether it is a maximum or minimum point. So you could do this in several ways. You could use the second derivative test, for example. Second derivative test. Where I simply find the second derivative of that, which would be what was the second derivative? We need to go up here. Here is the second derivative, so it is equal to 2. And that is larger than 0, so our function would be a concave up thing. So this will give us that 3 point minus 4 is a minimum point. Just one quick note. Our function here is given in a domain here. The endpoints of this function is not included. If it had been less or equal to, we would have had stationary points in the end, right? Because then we would have had some kind of function like this, where we had, sorry, wrong way, it should be concave up. So we had one minimum point here, and then we would have had these included, and they would be local maximums. But since these are not included, we will never get to the maximum point. We could always get closer and closer and closer to -1, or closer and closer to 7, but the endpoints are not included. So, to make sure, the endpoints are not included in the domain. So there are 3 cases where we could find stationary points. And that are where the gradient of the tangent is 0, that is the first derivative is 0. Then we have the endpoints. And then we have also if there are breakpoints. For example, if you have a function going like this, and then it continues up here. then we would have a minimum here. So you need to look at stationary points at all these cases. But in our case, we only have one stationary point. Since the endpoints are not included and we do not have any breakpoints because the function is continuous. Okay, that was this one, H. Determine the points of inflection, if any. Also determine where the function is concave up and concave down. Okay, we had that the second derivative is equal to 0, which is larger than equal to 2, larger than 0. So there are no points of inflection. Points of inflection is where the second derivative is equal to 0, and we cannot get that because it's always equal to 2. So it is concave up in the whole domain, like that. Okay, what is domain and range of f of x? You see, this is a fairly simple question to answer, even though it's down at I. The domain and range. The domain is given already. Domain is given as -1 larger than x larger than -1 less than x less than 7. Okay, we also need to figure out what is the range. So the range would be whatever, we don't know if this one is higher than that one or the other way around, but none of them are included. So we need to figure out what is the y value here and the maximum of these. So this would be the minimum range, and whatever is larger here would be the maximum range. So we need to find out the function, what it approaches when x approaches -1 and 7. So if we first let x goes towards -1 from the plus side, so we goes towards -1 from the right-hand side. That is very simple. We simply set in the -1. So it approaches 12. And then we goes towards 7 from the negative side. So now we goes towards 7 from the left-hand side. And we set 7 into the function. Like that. And that is also 12. So it never gets 12, but it approaches 12. The minimum was 4. That we found here, -4. So the range would go from -4 up to 12. So note here that we include -4 because we do get down to -4, and then we approaches 5. No, approaches 12. J. This was a really long one. J. Calculate the area between the graph of f of x and the x-axis from x equals to 2 to x equal 4. Okay, first we need to figure out whether the graph crosses the x-axis here. Because if it is beneath the x-axis, it would be the negative negative value of the integral, and if it is above, then we would have the positive area. So, when did it cross the x-axis? That we calculated early on in B, if I remember correctly. No, that was the vertical intercept here. The function intersects the x-axis and at 1 and 5. So from 2 to x equals to 2 to x equals to 4, it is beneath. Because we had here from x equals to 1 to 5, we need to be beneath because at 3 we have minus 4. So 2 to 4, we have the area between those. So the area would be minus the integral from 2 to 4. You could also use the absolute sign, like this, but then you need to make sure that you do not cross the x-axis between x equals to 2 and 4, because if you do cross it, you need to, let's say it crosses at 3, it doesn't, but let's say we need to split the area in 2. And the first one here, we need to have a minus sign because it's underneath, and then the other one, it's above. But anyhow, that's not the case here. Everything is beneath the x-axis. Okay, minus, and we set in the function x squared minus 6x plus 5 dx. We integrate 1/3 x to the third minus 3x squared plus 5x to 5. When I do this, I often find a derivative just to make sure. So we have 1/3 times 3x squared, and we get 3 times 2x and 5. So that's what we have here. It's okay. So finally, I get 1/3 4 cubed 3 times 4 squared plus 5, 4. That was the upper limit minus the lower limit. And when I press it into my calculator, I get 22/3. So the area would be 22/3, approximately 0.33. That was J. Okay, if we look at K, we need to sketch the function and mark the solution of all the others. And also, you can mark them even though you did not manage to calculate them. And the reason why you can do that is that, for example here, if you didn't manage to calculate the area, you could just mark it. You could, if you didn't manage to find a stationary point by calculation, you could do it by using the graph and so on. So we need to mark everything. Okay, let's go down to where we were. Here. I need to put in another site. Here, we're now in K. So we have here the x-axis, and as I've said numerous times, you need to name your graph, your axis, like that. So we had, let's say we had up to 7. Okay, 1, 2, 3, 4, 5, 6, 7. So that was our maximum, and 1 was our minimum. Wasn't that the case that our domain was from, no, -1, sorry, -1. Okay, on the y-axis, we don't need to have the same. So let's say we have 10 and 5. We don't need to have, here is 1, but we can make this as a 5. They don't have to match. We found that we crossed the vertical intercept here. That was in B. We found the crossing of the x-axis here in C, and that was also in C where we crossed the x-axis. The D, that was where we found the tangent. That was here with -3 here, if I remember correctly. And the minimum point was here. That was in G. And then we had this one and that one where we approach 12. So now we actually have the whole graph, or at least some points where we could sketch the graph. Okay, and on the whole domain, it is concave up. That was H. Okay, I think that's it. It don't have to be perfect, but we need to make sure that we do understand what we're doing. The area also, that would be this area here, which we will ask for in J. That is the area. Okay, I think that's it. And now we can do the last one. Wasn't L the last one? Whoops, here, yeah. Okay, by the way, I would have gone through B, C, D, G, H, and J just to make sure that I've marked all those solutions in the function. Okay, L, yeah. Calculate the volume created when the area between y equal to f of x and y equal to 0 from x equal to 2, x equal to 4 is rotated about the x-axis. So we will now want to rotate this area here around the x-axis. So the volume would be pi integral from 2 to 4 of f of x squared dx. Pi 2, 4, and we insert the function like that. Okay, so if we square this function, just put it in a little side note here. I first take x squared multiplied by x squared. Then I take x squared. No, I can do it a little bit easier. X squared multiplied by the whole parenthesis. So now I take x squared multiplied by all this. Minus 6x multiplied by the whole parenthesis. Then I have 5 multiplied by the whole parenthesis. Then I take the x squared and multiply it with each term. X fourth minus 6x third plus 5x squared minus 6x multiplied by each term in the parenthesis plus 36x squared minus 30x plus 5x squared minus 30x plus 25, which will give me x fourth. Here I have an x third, and here I have an x third, and that's it. So I get minus 12x to 3. Here we have x squared, x squared, and x squared. So I have 5 plus 36 plus 5. So I get plus 46x squared. And here I have x and x, so I get minus 30, so I get minus 60x. And finally the 25. Okay. That was a lot of side note calculations. You could put it on the side, or you could put it straight into the integral you choose. I like to take it on the side because then it's simpler to make sure I don't forget anything. Okay. Now I need to integrate. So I get x to the 5 divided by 5 minus 3x fourth, so that if we define the derivative, it gets 4x to the third, which is 12x to the third, which was what I had. Then I have 23x. No, I don't. That was to find the derivative. I should have one up, so I have 2 here and 3 there. And I need to divide by 3 in order to get 46. Minus 30x squared plus 25x to 4. And then we insert 4 first. 4 fifth minus 5 minus 3, 4 plus 46 divided by 3 times 4 third plus 25. So that was the first one. And then the lower limit. So I would get 406 divided by 15 pi, which would be more or less 85. What I haven't mentioned is that you should always check your answers. Let's say you have a cylinder here around the x-axis. And let's say that the radius of that would be, well, it's less than 4 and it's more than 3. So let's say it's 3.5. And the length would be from 2 to 4, so the length would be 2. The volume of that cylinder would be P times 3.5 squared times the length. And if you calculate that, you will get an approximate value for your volume. So let's say we do that. We take 3.14 times 3.5 squared times 2, which will be around 77, which is less than what you get, but in the same order of magnitude. Whoops, we got 85. So it's somewhat okay estimate. If we had gotten 100 or 1,000 or something in the estimate, our 85 would be wrong. Okay, so that was problem 4.